So, next section is archiving. And in this section, we'll talk about compressing and decompressing files and directories and archiving them. And we'll focus on gzip and zip and tar. So, how do you compress and decompress files and directories under Linux? And how do you create an archive tarball? So, the tarball is the archive. And we'll learn about compressing and decompressing files and directories with gzip, and also about how to archive or create tarball with tar. So to compress and decompress on Linux, that's generally done with gzip, bzip2, or zip. Gzip is a compression utility that's designed as a replacement for the command compress, and it has much better compression and it has no patented algorithms. And that's the standard compression system for all GNU software. So it's simply the recommended compression system. And there are some common options to it. And to see more of them, you can use man gzip or gzip --help. -d decompresses the files instead of compressing them. You can also use the shortcut, which is a gunzip, g-unzip. -r is recursively compress or decompress directories and their contents. And -k is that you want to keep the original files after the compression, because otherwise it doesn't do that. It removes them after the compression. So it will only be in the compressed file. And -v will give you a verbose output, and it will also show you compression ratio and other details. So let's do some examples, and please code along. The files and folders are in the directory exercises arch. And again, as for the other examples, they are in the tarball, which you downloaded in the beginning of this course. So you can find the link again also under this video. But it will be on the intro page. There's a link to the tarball that you will download and untar and uncompress, and then you can find exercises arch. So I will go back to the directory here. I had created an intermediate Linux directory just like before. I have the exercises directory that the tarball created when I untarred it. And then I will go into the directory arch, which is the one that has some files that are useful for this example. So first, I'm going to compress a file and remove the uncompressed file. So I will do gzip a file text. And when I do that, as you can see, I got the gzipped file here. And we could try and look at it and see that the size of it is 180. And I should have shown you the size of it before, so I will just do g-unzip a file. And then I will show you that it is larger now, as you can see here. So this is an uncompressed file, and this is a compressed file. And you also saw that in both cases, it removed the file when it zipped it, and it also removed the gzipped file when it unzipped it. So you could either use g-unzip or gzip -d to unzip it. Okay. So what if you want to compress a file, but you also want to keep the uncompressed file? Because maybe you just want to compress it to send it to someone or transfer it. Then you would use the option of flag -k. So we say gzip minus k, and we again take a file text. And if I then say ls minus l, you can see both of them are there now at the same time. So I can also compress all files in the directory. As you can see here, I have some directories to play with. And I'm going to show you how it looks in dir2. It has a subdirectory, and it has also some files. So I'm now going to do gzip minus r for recursive, and then on dir2. As you can see, it doesn't return any thing when it's just doing it. And you can't see anything here because it was in dir2. So let's see what is there. And as you can see, it actually did zip all the files under it. And it also did it in the subdirectory element. And you can also unzip the files again with gzip. And now let's do the minus d. And I also need minus r. And then dir2. And everything is now again unzipped. As you could see here, it does not also archive them as you might have expected from things like zip. It actually doesn't, it just compresses them. For archiving, tar is your friend, often combined with gzip. The reason for this is Linux usually believes in having tools that does one thing and do that one thing well. So you wouldn't use one tool that did both of it, but two tools that together does all of it. bzip or bzip2 is strong lossless data compression based on Burroughs Wheeler transform. It's also available as a library. It compresses better than gzip, but it also is slower. So that you're going to use if you have huge files, for instance, image files. Those you would almost always use a bzip2 on. So otherwise they will be very large, but it will take longer to do so, but they will be better compressed. Zip is a simple compression and file packaging utility, and that is the one that you may already know. Maximum size limit of zip files are 4 GB. And if size limit is exceeded, files become prone to corruption. And you can also get failure of extraction and inaccessibility of your data. So that's why you're not using zip in general. You can use it for minor things, of course. So let's code along for some examples with zip. And if I want to compress, see, I have my files here. I'll say ls minus l. And I have the gzip file. I'm just going to leave it alone. And then I'm going to do zip on a file. And I need to do it in the order that I tell it on the zipped directory. Zipped file first. So zip and the zipped file, and then the file that I'm going to zip. That. And it tells us how much it was deflated. And you can see here it zipped it. And actually, being just one file here, it actually didn't even help us because it zipped it to a larger file than it was before. Because that is how the file looked before. But that would not be the case usually if you were zipping several files or something. So if it already exists, you will be asked if you want to replace or rename. So let's try and unzip with unzipped. And I'm going to do that. Then it says this is an archive file that is zipped. Do you want to replace a file.txt? And if you say yes, it will do so. If you say no, it will probably just error out or end it. But you can also say rename, for instance. And since there could be several files in this zip archive, then you also have the option of all or none. But you could rename it. So let's try and do that. And then I get to give it a new name. Like that. And it says it's inflated. And I now have two identical files. So what if I want to compress all files in one directory into a single archive file? I can do that. I say zip, and then I say -R for recursive. And then I am saying I want to take dir1 and zip it. So I'm calling it dir1.zip. And then I'm taking dir1. And it shows us here what it's doing. It's not deflating it much, but it's doing a little bit. And now we have a directory or a zipped file here that contains the directory dir1 and all the files under it. You can also, of course, just like you could with gzip, compress all files of a certain type and directories under it to a single archive file. With gzip, it would not be to an archive file, but of course you could tell it to only zip files of, for instance, c or .text or .something. So you do for this zip -R, the name of the zip archive file. And in this case, I'm saying it's going to be in this directory. And -I to tell it what it is. And it's going to be files ending in .c. So let's try and do this because there are actually some files ending in .c here. And there's namely more file.c. And under the directory capital C, there's also some C files. So, zip -R, so recursively. And then I'm going to name it my C files.zip. And then I'm starting in this directory, so a dot. And then I'm saying what it is I'm looking for. And I need to put a slash here, because otherwise it would be unhappy with the asterisk. And then .c. And you can see here, it takes everything in the directory and below it, and it's zipping it, and it created my C files.zip. So now we know how to zip files, compress files, and also archive them with zip, or just compress them with gzip. But if we are using the recommended gzip to compress our files, we also need to archive them. Or maybe we do, but often we will. It could be that we just wanted to gzip them because we just want them to take up less space. But let's assume we also want to move them to an archive. And to do that in Linux, it's common to use tar. And this program will save many files together to a single archive file, and it will do so by concatenating them. And it will also restore individual files from the archive. The automatic archive compression decompression options exist. with various different compression utilities. So tar can work together with the various compression utilities. And there are also special features allowing tar to be used for incremental or full backups. tar ---- help is a command that will give the format defaulting to GNU. And this is generally only important if you have files that are larger than 8 GB. tar was originally developed for magnetic tape storage, like these guys here. Reading and writing data for a sequential I/O device that does not have a file system or didn't have a file system. The name is short for the format description, which was tape archive. But despite this clearly being something that was done a very long time ago, I believe tar was invented in the very early 70s. It is still being updated and still being used. So when you are making an archive with tar, it's usually called a tar ball. And tar balls can be compressed with gzip or bzip2, or there are also other options. It can be zipped with. And this is usually to give options and flags to do that automatically, so you don't need to do it afterwards. You can do it at the same time. And I guess I read somewhere that a tar ball is the name it was giving because you sort of should imagine a ball made out of tar that is rolling around among your files and picking up all of them, gathering all of them into an archive. So the syntax for tar. So tar minus options, and you actually don't need the minus in front of the options for tar. It does not care, which is unusual. But maybe it's easier to do it because, well, then you're doing it the same way for most commands. So then the name of the tar archive, you pick something, and then the files or directories which you want to add into archive. So options -C or --, there is an error here in the formatting. That should, in all these cases, the long version of the option should be double dashes. So, but -C is create a new archive. -A is auto compress it with some sort of compression that is determined by the name extension of the archive. If you, for instance, call it tar.tar.gz, then it will use gzip. tar.xz, then it uses xz compression. tar.cst for set standard, and so on and so forth. There are very many options. But the common one is gzip. -R is append files to the end of an archive. -X is extract the files from an archive. -F specify the archive's name. -T is to show a list of files and folders that are in the archive, so you could do that instead of just unpacking it. And -V is show a list of processed files, so it will simply output every file it encounters when it's unarchiving it. So let's look at some examples here. Again, in the directory exercises Arch. So let's generate a tar ball. And I'm going to go up one level. I'm just going to clear here to have a clean screen. Then I'm going to go up one level. And here we have some directories, including the Arch directory. I'm going to say tar. And I'm saying -C for create a new archive. I want to see all of them, so I say V for verbose, and F because I want to name it something, and I'm going to call it Arch. and then the tar. And then I'm saying it's the directory arch. And that means that it's going to create a tarball containing all these files and directories. And it's called arch.tar. It's here. Now, let's see if I could so gzip it directly if I wanted to, or I can extract the files. So let's see what happens if I'm extracting the files. So minus X for extract, V for verbose, show me the files, F, what is to give the name of the tar archive. So I'm doing that. And then it is on archiving it. Doing so, it overwrites without asking. So that is one thing to pay attention to. It will simply do it immediately. It will not ask if there's something already with the same name. It overwrites. Be careful. What if you wanted to do a tarball and compress it at the same time using gzip? Well, then you would again, we will again use tar and then minus. I am going to tell it that I'm going to use gzip, so that is set. And I'm going to create an archive, C, verbosely, and I will name it. I will call it arch tar gzip. That is a very common way of naming it. And then it's going to be this directory here. So it creates it. And it's here now, as you can see. And this is the one I created earlier that was not gzipped. So you can see it actually compressed it quite a lot. And if I want to uncompress and extract at the same time, I will do much like I did before, tar minus, and then set, because now it needs to use gzip to unzip it. And then X for extract, just like we saw before, verbosely, the file, arch, tar, gzip. And it each time it will unarchive and uncompress all of it. But it does not remove either the directory it works on or the tarballs or the gzip tarball. It keeps them. And it overwrites. So that is something to always be careful about. But you can always go up here and use this command here, -T on it. So if I said tar -T and then arch tar gzip, it was a missing F. You know which one it was. Then it will tell you what it's going to do if you are extracting it. So that is useful if you're not sure what is going to happen. It is also useful to check that it actually puts everything into a specific directory afterwards. So because someone might have been a little naughty and just taken all the files and stuffed them into a tar archive, but not having it in a top directory, and then it will just explode and you get all the files into the directory you are in, and you don't want that because then it gets mixed in with all the other files. You definitely want it to create the directory here, in this case arch. And that is what it almost always does. But with -T, you can check, you won't have any surprises. Okay, I think we are done with this section. We learned about gzip, bzip2, and zip, and we learned about tables and compressed tables. So it's time to move to the next section, which is the last section of this course.